Hi everyone, we're going to go through the practice CAT to prepare you for your CAT this week. So first up we're dealing with multiple choice, and we've got question 1 where we have to expand some brackets, and the first two terms are we're going to use FOIL, and so we're going to multiply the first terms and get x squared, the outside terms and get plus 6x, the inside terms get minus 3x, and the last terms you get minus 18. Then we're going to multiply negative 2x times both of the terms in the last bracket. We're going to get minus 10x plus 2x squared. Once we've done that, we're going to collect all the like terms. And we've got 3x squared, we've got 6x, take away 3x is 3x, take away 10x is minus 7x. And then we've just got the minus 18. And that's done. Have a check and see, is it A, B, C, D or E? And you can see that it's C, and circle C. Question 2. We've got x plus 1 squared, take away 4, and we need to factorise it. So what I would hope that you would do is to recognise dots, difference of two squares, and you can write it, well actually just recall that if I've got a squared minus b squared, it equals a minus b, a plus b. It doesn't matter which way those brackets are around, it can be a plus b, a minus b. So I'm going to write mine as x plus 1 squared minus 2 squared. And so I put the first term of both at the front. So there's the red one there, the x plus 1. That goes at the front of each bracket. The 2 goes at the back of each bracket. And then I have a plus and a minus. So I've got x plus 1 plus 2, x plus 1 minus 2. And then we can simplify that a bit more. We've got x plus 3 and x minus 1. And then just check and see what that matches up to. And it's D. Okay. Okay, question 3. We've got x squared take 4 over 3x squared minus x minus 10. So a fraction. And we're multiplying that by another fraction, 6x squared plus 7x minus 5, all over x squared plus 9x plus 14. And so we need to factorise each of those different terms on the top and the bottom. So lots of different factorising that we're going to be doing. So we're going to look at each separately. Okay, so I'm going to take first of all the top one, but we're going to look at them all separately. I'll just write that in. If you tried to do it all in the one go, it would get really messy. So I'm just going to look at x squared minus 4 and recognise that it's a difference of two squareds. So it's x squared minus 2 squared. And so I can simply do x plus 2, x minus 2. And that's that one done. Just a reminder to recognise that dots. Two terms, both squared, and you've got a minus in between. The next one, I should be recognising that this is a non-monic quadratic, so I've got a number in front of the x squared. And when I do that, I need to use my special technique of multiplying the 3 and the minus 10 and getting minus 30. Right, so NMQ is a non-monic quadratic, and I've got my minus 30, and I need the factors of minus 30 that are going to add to minus 1. So I'm thinking 6 and 5, and the 6 needs to be negative and the 5 needs to be positive. And what I do now is I break up that minus 1 into minus 6x plus 5x. And then I'm going to factorise 2 and 2. So the first two terms, 3x is common, and I'm left with x minus 2. And in the second two terms, 5 is common. So I take that out the front, and I'm left with x minus 2. And now what I can do is take out the x minus 2. Well, I'm actually going to take out the 3x plus 5 and then the x minus 2. You can do that either way. So that one's done. Now I'm going to look at the 6x squared plus 7x minus 5. And this is another non-monic quadratic. So we need to use that method where we multiply the first and the last term and we get minus 30 again. And this time I need it to add to 7. So I'm thinking of 10 and 3. So I need the 10 to be positive and the 3 to be negative. And that will add to 7. Now I'm going to replace that 7x with 10x minus 3x. And I've still got the minus 5. I do the first two. What's common? In the first two, 2x is common. And I need 3x plus 5 in the bracket. And if you look at the second part, we've got minus 3x minus 5, so I'm going to take out minus 1. And I end up with 3x plus 5. So I end up with 3x plus 5 and 2x minus 1. So that one's done. The last one is x squared plus 9x plus 14. And this is a bit easier. It doesn't have a number in front of the x squared, so it's a monic quadratic. And I just need to think of two numbers that multiply to make 14 and add to 9, and I'm thinking 2 and 7, so that was pretty easy. Okay, so now I have to put this all together. So I'm going to rewrite the question on the next page with the factorised form. Okay, so you can see I've replaced all of my unfactorised terms with, or expressions with, factorised expressions. And now I get to the fun part. I get to cancel out the x minus 2 on the top and the bottom, and the x plus 2 on the top and the bottom, and we've got a 3x plus 5 on the top and the bottom. And I look along the top line and I'm only left with 2x minus 1, and on the bottom line I'm left with x plus 7. And if you have a look at the multiple choice, it's answer B. Okay, number 4. X squared minus 8x, and we want to add a number to make it a perfect square, and then the question is asking for what is the actual perfect square expression. So we kind of have done this a lot when we are completing the square, but we haven't had a question quite like this. So we want the number that needs to be added to make a perfect square. So normally we would halve the middle term, and that minus 8x is the middle term. So we're halving it and we get minus 4, and then we square that and we get 16. So I just got to square that minus 4 and get 16. And then add the 16. And then those three terms will factorise to make 8x minus 4 all squared. And so that tells us that it is answer E. All right, question 5 gives us another expression to factorise, but it says factorise by completing the square because there are no factors of 3 that add to negative 2. So we'll go through the process. Halve the middle term. So half of the middle term is minus 1. I always put that circle around it, and then I square it, and I'll get 1, and I add and subtract the 1. So x squared minus 2x plus 1 minus 1 plus 3. The first three terms form that perfect square. So it's x minus 1 squared. And what's left over is just plus 2. So we should recognise that this is actually not a dots. It looks like one, but it doesn't have the negative, and so it can't be factorised. And because of that, we have to look at our options for the multiple choice, and the answer is E. Can't be factorised. So our next question is to find the solutions to x squared minus 12 equals 0. So I'm going to write it as a difference of two squares, but I'm going to force the 12 to be a square, and I'm going to write it as square root of 12. So my next step is to write x minus root 12, bracket, x plus root 12 equals 0. Now each of those brackets from the null factor law will equal 0. So x minus root 12 equals 0, or x plus root 12 equals 0. And now we get the x by itself, so we move the negative 12, root 12, over to the right, and we get x equals square root of 12. So the first one will be x equals the square root of 12, the second one will be x equals negative root 12. So you get two solutions to the question. Now, we should really simplify any surds if we can, and you know from your work at the start of the year that square root of 12 can be written as the square root of 4 by 3, and which can be written as 2 root 3. So just simplifying those, and then that allows us to check our answers, and we get our answer D. Okay, question 7 gives us another expression, or actually an equation, to solve for x. And we want the factors of 4 that add to negative 4. And you may actually figure out that it's a perfect square, but we can just do our usual method. So I've got minus 2 and minus 2. So I've got two brackets that equal 0, so I'm going to make each one equal to 0, and then each one will actually be x equals 2. So for this particular question, there's only one answer, x equals 2, and the answer is C. Question 8, we want to find the solution to this equation. Now it looks a bit unusual because you've got a divide by x, and we usually don't like having those fractions. So the first thing I'm going to do is to get rid of that divide by x by moving it. So if it's a divide by x, I can move it to the other side of the equal sign by doing the opposite sign, timesing by x. And when I do that, I will still have 3 bracket 9 minus 2x equals x squared. I'm expanding the bracket, and I'm actually going to move everything over to the right. Well, this is how I expand the bracket first. But now I'm going to move everything to the right so that I've got a positive x squared. Usually I would say move everything to the left, but I'm going to do it this way because if I move the x squared to the left, it would become negative. All right, so we end up with 0 on the left-hand side and everything else on the right. And then I have to think of the factors of negative 27 that add to 6. So I'm thinking 9 and 3. So 9 and 3, so 9 and negative 3 will add to 6. So x plus 9, x minus 3. And then each of those brackets equals 0. And so x equals 3 and x equals negative 9. So for question 8, that is answer D. Okay, question 9 says, find the value of the discriminant for the equation given. Now, we know that the discriminant is often called delta, and it's b squared minus 4ac. So my a is 2, my b is 3, my c is negative 1. So I'm just going to put those numbers into the formula, and I get 9 minus negative 8. So delta is 17. And I don't have to interpret that at all, so it's just answer E. With number 10, it says if a squared plus bx plus c equals 0 and it has no solutions, then what do we know about delta? So you should know that when there are no solutions, that means that delta is negative. And so if you look at the multiple choice options, we would like b squared minus 4ac to be less than 0. And that gives us answer B. Now, I think somewhere along the line in this, I've left out question 4. I'm not sure, but yeah, sorry about that if I've done that.